Okay, so continuing with our polynomial functions, we want to talk more about how we can graph them with and without a calculator. Okay, so first of all, this is a word that we didn't talk about last year in Algebra 2, something called multiplicity. And so multiplicity, it says if a zero occurs twice, it has a multiplicity of 2. So a factor x minus a to the k, where k is greater than 1, yields a repeated 0 if it has multiplicity of k. If it's odd, it'll cross the x-axis. We already said that. If it's even, it just touches the x-axis. But what happens as the numbers get higher? And so I said, let's graph these two and see what happens. So what I have, oh no, not that. This is what I have. I graphed y equals x minus 2 squared, which we know means it's moved over 2 and it has a repeated root. But what happens if I make that to the 4th power? To the 4th power. So it's still over there at 2 as the 0, but what happened to my graph? And what if I go a little bit further? What if I do x minus 2 to the 6th power? So what happens here, look, you can pick all the ones you want. As you zoom in closer and closer to this graph, zoom in, it looks like it's really flattening out there, right? It kind of looks like it's touching in more than one spot, but it really isn't. But what's happening is this is x squared, or x minus 2 squared, this is to the 4th power, this is to the 6th power. So the higher the multiplicity, what happens to the graph? The more it flattens out there, right? What happens if I change this back to, what if I change this to an odd number? If it was just x minus 2, that's just a line. If it was x minus 2 to the 3rd, that's where we get that little curve in our x cubed graph. And if it was to the 5th, it still curves, but again, what's happening here is that we are flattening out. But the difference is when it's odd, it crosses the graph. And again, look at the blue one. This is the cubed. Then look at the green one. This is the 5th power. So the higher the multiplicity, the more the graph flattens. That we really need to write all that, but x minus 1 squared kind of looks like this. And then when I do to the 4th power, oh, that's not minus 1. Where does the minus 1? Minus 1 would be over here, right? At 1. But then when I do to the 4th power, it kind of looks like that it touches longer, but it really still only has 1 0. So I think you should write this. The higher the multiplicity, the more the graph flattens out on the x-axis. And you can go to desmos.com/calculator and investigate that more, okay? What I want to do is I want to talk about how to graph this. So it says state the degree and list the zeros. State the multiplicity of each zero, and if it crosses or just touches, and then sketch the graph. And so without a calculator, I want you to be able to make me a pretty good graph, okay? So just like we did on day 1, state the degree. Well, if I multiply this together, that would be negative x to the 4th, right? So that's going to be degree 4. Go ahead and think about in behavior. It doesn't say this, but degree 4 and it's negative. What do I know about the arrows? Well, I know they should both be pointing down. What about the 0? Since this is already factored, do I know that this has a 0 at 0 and at 2? But now what do I know about the multiplicity of this? Well, at 0, it has a multiplicity of 3. And at 2, there's nothing out there. And so don't say a multiplicity of 1, because a multiplicity of 1 doesn't do anything to the graph. So we say it has no multiplicity. But because there's a 1 out there, it's an odd number, what do I know about both of these? Both of these are going to cross the x-axis. Did I answer all that stuff? State the degree, list the zeros, multiplicity, crosses or touches, sketch the graph by hand. So I gave you some steps here. Leading coefficient test, that's the end behavior, right? That's what I did right here. Find the zeros. Find the y-intercept if easy to find. So I'm going to put if easy. And then graph points in between. So what do I know right now? I know there's a 0 at 0. I know there's a 0 at 2. And I also know my end behavior, which I know this side goes down and this side goes down. So on this one, I already found my y-intercept because it's 0. So I'm definitely going to pick 1 here. And I'm just going to plug 1 into this problem. So if I do f of 1, that's going to be -1 times 1 minus 2. Or -1 times -1 is +1. And what do I know? Well, I know this side, it just goes straight down. Let's say you're not sure. How do I show this? Let's pick another point just to make sure. If I plug in -1 here, that's going to become -1 to the third is -1 times a negative is a +1. And -1 minus 2 is -3. So at -1, it's at -3. 1, 2, 3. What if I pick 3? If I plug 3 in there, oh my goodness, that's going to be 3 minus 2. But then -3 to the third is -27. So think about, because at 2 it has no multiplicity, it's just pretty much going straight down. But because at 0 it has a multiplicity of 3, I know that it should do that little curve like we saw in the graph. So I'm going to make this kind of come up and go like that. And that's a pretty good graph. Domain and range of these should be, well, the domain should be all real numbers. Because this is both pointing down, the range would not be. Oh no, what just happened? Goodness gracious. Okay. Let's do another one. How many more do I have? Oh my gosh. Oh my gosh. Okay. So what about this one? If I'm going to graph this, where's my time? 7 minutes. What do I know? Well, if I multiply this out, this would be x to the third times x squared. So together, that would be x to the fifth. That's an odd degree. So what do I know about the arrows? Well, that means the left side's going to go down and the right side's going to go up. You don't have to write the infinity stuff if it doesn't ask, but you need to make sure your graph matches the arrows that you know it should be. What else do I know about the zeros? Well, if I set that equal to 0, I'm just going to get x equals 1. Multiplicity of 3. And since that's odd, I know it's going to cross the x-axis there. If I solve this one, I'm going to get x equals -2 with a multiplicity of 2, because that's the exponent, which means it's just going to touch. It shouldn't cross the x-axis. So if I just graph those zeros at -2 and +1, I'm going to draw this in because I might go back and erase it, so maybe you don't do it yet. I know this side should go down and this side should go up, so I don't always pick a point out there, but I do need to pick these points in the middle. So like I'm definitely going to pick -1 and 0, and that's where you can use your calculator, but -1 minus 1 would be -2 to the third, and -1 plus 2 would just be 1, so that would be -8. So at -1, 1, 2, 3, 4, 5, 6, 7, 8. And that should make sense that this side's going to come up and touch and come back down, right? And again, I can fix it in a minute. And if I plug 0 in there, that's just going to be -1 to the third times 2 squared. So that's going to be -1 times 4, or -4. 1, 2, 3, 4. So smooth curves, no jagged edges. So I'm going to go back and erase this a little bit because I want to make it look nicer. I know that I want this to kind of flatten out a little bit, but not too much. And this side's going to go down. This one's going to come down and turn up like this. And then at 1, it has a multiplicity of 3, right? So I need that to look like that x cubed graph, like this. So I'm going to come up and kind of flatten it out and make it look like that. Mostly I need it to not look like this. I need to be able to see that you knew there was a multiplicity there. Okay, and that's a pretty good graph without doing a lot of work. Okay, What about this one? Using only algebra, find a cubic function with the given zeros. And then this one we'll do in class. Okay, so if these are the zeros, it's like saying x equals 3, x equals -4, and x equals 6. I just want to go backwards, right? So the factor would be x minus 3, the factor would be x plus 4, and the factor would be x minus 6. Write a function, right? So you need to say y equals or f of x equals here. And then also I want you to work it out, all right? I know there's going to be one like this in your future, and I'm going to tell you to work it out. So you need to FOIL this out, which would be x squared plus 4x minus 3x would be plus x minus 12. And then you need to multiply by x minus 6. And so we'll check in class and see if we have the same answer or not. And then tomorrow in class, we'll talk about what if we ask you to graph it using a calculator? How is that different? And do we know how to do that as well?